Dear students, hope you are fine and are safely inside your homes amidst this corona scare. We will resume our studies through this medium for next a few days until things are put in proper order. In today's video lecture, we will study asynchronous ripple counter, which will count the clock pulses in the digital wave. Means how many clock cycles are there, how many clock cycles have passed in the clock pulse. Before we start before we start studying the design of a ripple counter, we will first recall how does a JK flip-flop works. For this I have taken the truth table of a JK flip-flop which has two inputs J and K and two outputs Q and Q complement. Major output is Q, so we will not focus on this too much. So first combination of inputs is 0 0. As you know, for this combination last value will be retained. Similarly, the other combination of inputs is J 0 and K is 1. So for this your flip-flop will be reset. And for the next combination 1 0, your flip-flop will be set to 1. And the last combination 1 1, which is actually not allowed in RS flip-flops, but this is perfectly valid in JK flip-flops. This is most important for in the study of ripple counters. This combination 1 1 combination provides toggle state. Means whatever the value of flip-flop is, it will toggle. If it earlier contained 0, it will store now 1, and if it earlier contained 1, it will store 0. So this is the most important combination of inputs for our purpose. Now I move on to the design of a flip-flop, design of a counter. So for this, for a basic counter, let's now start studying the circuit design of a counter. We have three JK flip-flops, which are named as A, B and C. All of them have inputs JA, KA and the major output QA. Similarly JB, KB and QB, JC, KC and QC. All the three flip-flops are negatively edge triggered. Hope you remember what does this mean, negative edge triggered. So all of them are negatively edge triggered. Now J and K inputs of all the three flip-flops are connected to each other like this. And after exact combination, a high signal is provided at this terminal. This high voltage, high signal is fed at JA, KA, JB, KB, JC and KC. Means all the J and K terminals of all the three flip-flops are set at high voltage. So they will be in the toggle state. For example, flip-flop A, its J value is high, K value is also high. So for this combination, this flip-flop is in toggle state. Similarly, B and C flip-flops are also in the toggle state. So now let's complete the circuit. This clock signal of the first flip-flop is provided the actual clock pulse. The clock pulse whose clock cycles we are to count. And the clock signal of second flip-flop B is not provided the same clock pulse. It is provided the output of its previous flip-flop. Similarly, clock signal of C flip-flop is fed the output of its previous flip-flop, that is QB, and this is the final output. So now this is the circuit connections. Once again I repeat, first flip-flop is fed the major clock pulse, second flip-flop is fed the output of first flip-flop, and similarly third flip-flop's clock signal is fed the output of the second flip-flop. It is mention worthy here that all the flip-flops are fed by different pulses at clock signals, not by the same. Therefore, it is asynchronous device. Okay, now let's study how do they work. Bear in mind that all the flip-flops are in the toggle state, but all of them are negative edge triggered. So they will toggle only when they find a negative edge at this terminal. So now let's suppose this is the clock cycle, clock pulse, which is feeding the clock terminal of the first flip-flop. Hope you remember how this digital pulse is studied. In this direction time lapses. So if I take a straight line horizontal to parallel to this, I will mark all the negative edges. This is the first negative edge, second negative edge, third, fourth, fifth, sixth, seventh, eighth, and so on. Let's number them: 1, 2, 3, 4, 5, 6, 7, 8. Now this is the clock signal. Now this clock signal is provided at this terminal, clock signal of the first flip-flop A. Now let's study how this flip-flop will work. So its output QA will be represented by this pulse. Let us suppose it starts at 0, means low level. So it will toggle whenever there is a negative edge. So you have a negative edge here, so it will toggle here. Another negative edge is on this location, so it will toggle again. So it will toggle again at this location. Hope you understand why does it toggle, because it is provided high signal at J and K terminals and it is negative edge triggered. So therefore at every negative edge they will toggle. Starting from 0 it becomes high, then low, then high, then low, and so on. So now let's focus our concentration on the flip-flop B. So its output also will be achieved in the same form, pulse form. So again this flip-flop is also in toggle state, 1 at J, 1 at JB, 1 at KB. So this flip-flop is also in the toggle state and it will toggle at the negative edge, but negative edge of this pulse, not this pulse. So we will ignore this pulse now, we will focus on this pulse now, because this is feeding, QA is feeding to B. So whenever there is a negative edge of this clock pulse, I haven't toggled here because this is the negative edge of this pulse, not this. Here it is positive edge. So negative edge of pulse QA is here, so it will toggle. Next negative edge is here, so it will toggle at this point. Next negative edge is here, it will toggle. That next negative edge is here and it will toggle, and so on. Hope you understand it. Similarly, we move our focus on the flip-flop C. Again, C flip-flop is provided high signal at JC and the same high signal at KC. So 1-1 combination, therefore it is also in the toggle state. Again, it is also negative edge triggered, but the difference is that the clock pulse feeding to this flip-flop is neither this pulse nor this pulse, it is rather QB. So QB, this pulse will be feeding it. So now if we study the output of third flip-flop QC, it will toggle at the negative edge of QB. So if it starts at 0, it will toggle at this point because negative edge of QB has arrived, and then it will toggle at this point, will not toggle at this is positive edge, negative edge it will toggle, and so on. Now let's study what have actually happened. In the beginning, all the pulses QA, QB and QC are at low. So I write 0, 0, 0 in the beginning. At first negative edge, this pulse has risen to high voltage. This is low and this is low. At the second negative edge, this becomes low, this becomes high, this remains low. At the next negative edge, third negative edge, it is high, it is also high, this is low. How do I mark them 1 or 0? If it is high, I write 1. If it is low, for example, this is high, I write 1. This is low, at lower level it is 0. Similarly, at fourth clock cycle, 0, 0, 1. Fifth clock cycle, it will be 1, 0, 1. Sixth clock cycle, it will be 0, 1, 1. And similarly at 7th, 1, 1, 1. And at 8th, 0, 0, 0. So if we take this as the least significant bit and this as the most significant bit, we write it like this: 0, 0, 0. At the next clock cycle, it becomes 0, 1, 0, 0. At the next one, and 0, 0, 1, and further. So if we complete it like this, this is 0, 1, 1, and at the 7th clock cycle it becomes 1, 1, 1, and after this it becomes 0, 0, 0. I repeat, this pulse QA is least significant bit, so you write it on the right hand side, and this is the most significant bit, you write it on the leftmost side. So now observe this is binary 0, this is binary 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, and this is 0. So what you have got, clock pulse whenever there is a negative edge means end of the clock cycle. Its output becomes 1 from 0, and whenever there is next negative edge means one more clock cycle has passed, then it becomes 2, and at the lapse of another clock cycle it becomes 3 and 4, 5, 6, and similarly, and after lapse of 7 clock cycle it is 1, 1, 1. Now this is the limit, maximum capacity of a clock of this counter. After this 7 it is reset to 0, and if you enhance it further you will find that it will start recounting as 0, 1, 2, 3, 4 and so on, and until 7. So now if you want to extend your counting, you can have another flip-flop here, you can attach it. So depending on the limit of counting, you can have more and more JK flip-flops connected in the similar manner. So hope students you have understood how does this counter behaves, the counter works. I advise all the students to read this topic from your books thoroughly and then prepare notes. Thank you very much.